Hey everyone, welcome back to this week's episode of Project JoyBoy. In last week's episode, which was an update video, we removed the engine, the swing-on pivot shaft, and all of the other internal combustion engine parts that we no longer wanted. In this week's episode, we'll begin 3D scanning the frame using this CR Scan Ferret, and then we'll also begin some of the CAD modeling for the parts to make sure everything can fit. This is the most crucial step for the project and ensuring that it's executed to the highest level. So let's go ahead and get started. To make sure our battery pack and our cooling system fits properly, we need an accurate model of the 3D frame in the software before we begin to model anything. And so some of the key components or key things to look for are just the overall shape of this, the dimensions of it, as well as the exact width that I'm gonna have and how I will fit all of the other components that go with this, the BMS and the active balance. Here is our 3D scanner. And so it pretty much comes in a few pieces. This is the Creality CR Scan Ferret. I want to say this is the Ferret. Whichever is the smallest and cheapest one that they sell, because they do get pretty expensive. So we have a cable that goes from the, I want to say, the receiver to whatever device you are using. So in that case, it'll be my laptop. We kind of have the stand and the battery bank. Okay, so here we have a phone holder. Typically, you will put the phone holder right under it in a way like this, and then the gimbal that holds the scanner would sit on top, but I use my laptop, so we go ahead and just delete this part. So now I'm gonna bring you guys over and kind of show you what this part of the setup side actually looks like. So here are the scans. One of the things that people talk about this scanner is that it loses its tracking, and it's kind of difficult to keep tracking and be able to scan a large model such as this bike. And so what we have here, I think, is good enough for us to be able to put into Fusion 360, scale up, and begin to design around. So let's go over to Fusion 360 and I can show you guys some of what that looks like. So here's the bike in Fusion 360. As you guys can see, this is a different scan than what I showed in the previous clip. After messing around with it, I went back over and I wanted to get a better scan of the bike, something that added the wheels and some of the shocks and just some of the more details of the frame. That way I had a more complete scan before I started to model anything. And so one thing that Creality does whenever you put it into the software is that the scan doesn't have a size. It's honestly, I think it was huge, really, really big. So I had to scale it down all the way down to like 0.39 or something like that just to get it to be the appropriate size. Now, I don't know how accurate the sizing of this model is compared to the actual bike. So one of the things I did decide to do was to just test out the enclosure, just take this, scale it down to the best way I could, draw up the enclosure and move it over to where I can split it up and print it. So the printer I have is the Creality Ender V2. And so the build volume for the Creality Ender V2 is, I want to say 250 millimeters by 250 millimeters. And so what I did was break this enclosure down to where I could print it out in 7 by 7 inch blocks. So the total volume or area of this, which is within the 7 by 7 area that this printer can print. So I split it in half and printed from laying it on its side, so that way it printed up. But this did introduce problems because of the height. Now, the height can print up to 12 inches or 11.8. So I assumed that this was going to be a good size if I split it in half and only print 6 inches. So after the failed print and just overall being sick of this Ender 3 V2 and always having to work on it and tinker with different things, I wanted something that worked out of the box, that was much faster and just newer. So I found the Creality K1 on sale. So here it is. We'll go ahead and get it out of the box and get set up. The speed of this printer completely took me off guard. Compared to the Ender 3 V2, it is way faster. And so with the first test print printed out and everything looking good, I went ahead and ran my first part of the enclosure. It was at this point I decided to take a break from the just working on this project and go out to SpaceX and just see what Elon Musk and all that stuff out there he's got going on. And it was really cool. So here's a few clips from that. And of course, I had to work on the project while I was on the way out there because I just couldn't stop thinking. So now we're back at the workshop and we have printed out all of the pieces for this enclosure, and we can go ahead and begin to hot glue these different parts together to get a test mock-up and see what it looks like on the actual frame. So we've completed the enclosure, hot glued everything together, and here is what it looks like completed. One of the things I am worried about is the seams at which the plastic meets together. So I made this to where it's kind of tight. I want it to fit the frame perfectly, but there is a slight bump from the hot glue seam. So we'll see how that fits whenever we try to insert this into the frame. So now that it's time to move this enclosure and test it inside of the frame, I began to have trouble. It was at this point I thought that maybe the geometry was wrong, maybe the scan was wrong, or that it just wouldn't fit. So I was kind of starting to panic here, but after a careful inspection, I noticed that some of the tabs on the frame were causing us fitment issues, and so with the tabs cut off, we are now able to get the enclosure in again for its second fitment. This time, it went pretty well. The shape was able to fit inside of the frame until it got to those seams, at which I had hot glued it. But I knew if I just kind of forced it in a little bit, I had no worries because the actual metal part of this wouldn't have those seams and it would be perfect. So went ahead and pushed through and pushed it on in until we hit the second small tab. So overall, I'm pretty excited about the fitment of this enclosure on the frame, and everything turned out mostly how I wanted it to be. So this front angle here, that fit exactly how I wanted it to, same as this second angle. Now this third one, it's a little bit off. You can tell that I need to slide it back a little bit and maybe drop the vertical point down. And then as far as this 90-degree here, that's perfectly fine. It's just not straight from the hot gluing, but everything else fit exactly how I wanted to. And so with this, I'm now confident enough to move over and actually fabricate this using SendCutSend. So here is the sheet metal drawing in Fusion 360, and you can see the original sketch of the enclosure that I printed versus me having to then create this out of sheet metal. And SendCutSend has several requirements when you're bending stuff out of any material. You can't have bends that are too close, and neither can you have bends that are bump bends. And so here you can see that I had to try several different versions of these bends in order to get it to comply with their requirements. And even after I got it to fit in with their software let a few mistakes slide through, and I still had to backdoor and go back and change and edit the file yet again. So I've been working on this project for at least maybe 2 years now of just kind of slowly accumulating different parts and different things like that. And so to be able to finally see this enclosure, or at least part of it, sitting on the bike and everything is fitting exactly or close to how I want it to feel is truly a major step, and it's giving me motivation to go ahead and finish the project and keep on pushing through. So thank you guys for making it to the end of this video.